Thanks, Nick.
Okay.
You guys were right on time. Amazing. Well, hey, everybody. Welcome to part two. This is John Gates. Thank you very much for joining. Thank you for Ben and Nick for the reminders and the product updates on installation. I hope everybody's install season's going great so far. But Tom's got some, I think, hopefully intriguing and helpful information to share with you on CropX's new device line of actual ET. For those of you that were with us at the dealer conference, you will have um, heard about this already. For those that aren't, some of this info might be brand new. And I hope you find it very interesting and potentially useful to your operations. Just real quick before I hand it over to Tom, wanted to do an intro for those that haven't seen him or talked to him before, but we're very fortunate to have Tom on board. Tom is one of the top scientists in the world on plant water interactions. He was the inventor of the technology that he's going to be talking about today. He was also the CEO of Thule Technologies, which is the company that innovated this and commercialized it for the last 10 years. So Tom, over to you. Thank you.
Thank you for the generous introduction, John. That's very kind. That will buoy up me for the rest of the day because I'm just getting started here over in the West Coast. I'm going to share my screen with a presentation. Give me just a moment. Oops. Let's see. There we go. Okay, so there's a few things that I would like to talk to you all about today. The first thing I would like to tell you about is how there's different kinds of ET,
Hey
and
Tom,
what.
can you switch to your other screen? It's got the presenter view.
Got it. Thank you.
You're good.
This one. Is that better?
Perfect. Got it.
Okay. Thank you, Nick. Um, so the first thing that I'm going to talk about is that there are different kinds of ET and that the ET that CropX is providing is very different than the ET that you and your growers have previously heard about. It's a direct measurement of the actual ET and not an estimation of the ET of a lawn. The next thing I'm going to tell you about is the history of how we developed this technology and how it works. Then I'm going to show you more about the CropX ET solution, what the hardware looks like and what the data looks like. And then finally, we're going to end off with some talking points for your growers. So the first point that I would like to make, jumping right into that, um, is that not every ET that you hear about is the same thing. In English, we tend to be lazy about our use of scientific terms. And for the last 50 years, when people have been talking about ET, they should have been saying reference ET every time they said ET. The ET that you get from a weather station or that you get from a weather network is the reference ET. The reference ET is a model that takes weather data as an input, and the output is an estimation of how much water a well-watered lawn would use. Another way of thinking about reference ET is it's just a proxy for the atmospheric demand for water. It just tells you about the weather. It's really telling you, here's how much, here's how the weather is different today compared to yesterday, if we're thinking about it from the perspective of what a plant experiences. So the reference ET is the sort of thing that you'll hear on radio reports, or you'll see in apps, or you'll get from a weather station. Reference ET is not what the new CropX actual ET is providing. Reference ET is a model and it's an estimation. And this is going to come up again and again when you talk to growers. It's certainly come up for me over the last 11 years talking to growers. They've said, ET, I already have that. Why would I need that? I get that from the radio. And what we're doing is different. It's a direct measurement of what's happening in your field. let's move on to another type of ET we'd like to talk about. And this is called crop ET. So one way of trying to make reference ET more useful is um, you turn the reference ET measurement into, or estimation, into a estimation of your crop ET. So you're saying, okay, I'm not growing grass, I'm growing corn. So I'm going to just take some multiplier and adjust that value for a well-watered lawn into a value for corn. And you do this with something called a crop coefficient. You're all familiar with crop coefficients. So you take that reference ET value and you multiply by one crop coefficient value to get the crop ET for corn. And that crop ET is telling you, okay, you have this idolized corn canopy, this idolized cornfield. It's not experienced any water stress. The canopy is exactly like the canopy where the crop coefficient for this field was, or for this crop type was originally developed. It's no smaller, it's no bigger. And this is the estimate of how much water this perfect platonic vision of a cornfield uses. And of course, that's not true. I mean, how boring would agronomy and farming be if every field was perfect? You'd realize that you'd actually probably died and weren't experiencing the real world if every cornfield you walked into was exactly the same and had the same perfect canopy and no variability. So crop ET has limited utility because it's not telling you about the water stress of the field or variations in the canopy size. It's just saying, here's an estimate of how much an ideal cornfield uses. Again, this is not what CropX is providing. And growers are going to say, well, I've already got crop ET. Why do I need actual ET? And the answer to that is, well, your crop ET is assuming that your field never experiences any water stress in between irrigation events, and that your canopy is exactly like the canopy at the Kearney Ag Lysimeter in Bakersfield, California, where they first estimated where they developed that crop coefficient value for corn. So it has limited utility because it's just an estimate. The next type of ET that I want to bring up here is model ET. So you'll see a lot of remote sensing platforms that will give you an estimation of the water use of the plants of the actual ET. And the key point here is that these remote sensing based methods, where they're just using pictures from space, they're biased, and we have no way of knowing how biased they are. They're either way too low or way too high. And the only way you can really know if they're too low or too high is if you have a sensor on the ground, like the CropX ET sensor, measuring the actual ET and comparing it to what's coming from the satellite. The reason they're biased is the main reason that the main way these satellites work is they look at the air temperature and they compare that to the satellite measured canopy temperature. They measure the satellite, excuse me, they measure like satellites measure the canopy temperature by looking at the infrared radiation emitted from the canopy. And the theory there is that ideally, if the plant canopy is if the plant canopy is the same temperature as the air, then your plant is water stressed and not is not transpiring like it should. The reason that would be is if the plant is not transpiring, it's not cooling itself, and therefore it's the same temperature as the air if it's not transpiring much and it's water stressed. The flaw in this logic is that if it's a really windy day, you're gonna have an actively transpiring canopy, and it's still going to be about the same temperature as the air, because that air is constantly moving across the canopy and re-equilibrating the canopy temperature with the air temperature. In other words, you have to know something about how the wind is transporting heat and water vapor to really understand the difference, to really understand how the air temperature and canopy temperature relate to ET. Or said another way, you have to have a turbulence sensor in the field that's measuring the efficacy of the turbulence in the wind, to understand to do remote sensing ET well. And it just doesn't happen. Like all those different models that you see out there, that are available through remote sensing platforms are not being ground truthed with actual ET sensors. So they're just estimates. If I were a grower, I would use, if I had only the choice to use between model ET and crop ET, I would use the crop ET, because the model ET, you just have no idea how off it's going to be and what assumptions the people that built the model are making. Or at least crop ET, I like have an idea of like, okay, I know they're assuming that my field is well watered and has a perfect canopy, so I know it's an overestimation, and at least I can like work with that. Whereas model ET, it's like, to me, it's garbage because you don't know how far off it is, if it's too high or too low. So we've covered 3 different types of ET now. Reference ET, crop ET, and model ET. And growers are going to push back when you're telling them that you have actual ET available and say, well, I already get that from remote sensing, or I already get that from my weather station, or I got that from the crop ET. It uses a crop coefficient. And what you have to remember when they say that is like, those are all just models and estimations, and they're not telling the farmer about what's going on in their field. And that's where actual ET comes in. With actual ET, you're measuring how much water that field is using. It's a direct measurement of how much water those plants are using over a broad area. It's telling you that it's telling you about the water stress. It's telling you about the canopy size. If you have a small canopy, your ET will be smaller. If your plants are water stressed, your ET will be lower. So everything about this is a measurement, an agronomic measurement that's telling you about what's happening in the field. Let's talk a little bit about the history of how this was developed. So that the technology behind this is called surface renewal. Surface renewal was first developed in the 90s. So a pretty good amount of time ago now. And when it was first developed, researchers showed that they could measure the ET really well with surface renewal, but they were always off by some calibration factor, and they didn't know how to predict that calibration factor. So there's a body of literature that exists for 20 years that shows that surface renewal works really well if you, but you just need to calibrate it. And then once you get that calibration factor, it works incredibly nicely, and it's been validated against lysimeter measurements and eddy covariance and other, academic methodologies for measuring ET. In the around 2010, I started my PhD work because I wanted to figure out what that calibration method was, like how to obviate the calibration. I wanted to figure out how to make this surface renewal technology something that farmers could actually use, and could be something that's commercially available because it doesn't require expensive calibration against expensive academic methodologies. So I did my PhD work on figuring out the turbulence science behind this, and eventually figured out how to calibrate surface renewal without these academic tools. So that's what enabled the start of Thule. Another way of saying that is that we're standing on the shoulders of giants here. Like CropX didn't come up with this technology out of thin air. Instead, people have studied turbulence for a really long time, even using like really cool analog devices to study atmospheric turbulence before the invention of modern computing. And those theories were the basis for the theories and the data around measuring ET with more academic and expensive methods like lysimeters and eddy covariance. And then surface renewal was built on top of those concepts. So surface renewal is standing on the shoulders of the giants before them. Then my work in academia was standing on the shoulders of the giants who developed surface renewal and my work was to figure out how to make the calibration work. And then now CropX is standing on the shoulders of all that academic research, decades of academic research showing that this technology works. In fact, there's a lot of papers out there that if you really want to read an academic paper, we could send them your way, but generally it's almost like it's an idle threat, and that farmers will sometimes ask me, like, well, show me the data. I'll be like, okay, here's a paper. And they're like, whoa, 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 don't make me read a science paper. Okay, I believe you, I believe you. But we have that available. We also have a white paper that kind of describes more of it in layman terms that you can share it with. You can share it with growers if they do ask more about how the science of this works. Anyway, going back to the commercial story of what we've developed here, I've kind of told you about the scientific history of it so far. Now I want to talk about the commercial history of it. So in 2014, after developing the technology in academia, I brought this technology out into the world, started a company, and we worked with, before Thule was acquired by CropX, we worked with hundreds of growers in California over more than 1,000 fields per year. And we worked in all sorts of crop types. We're primarily in the perennial crops grown out here in California, like grapes and pistachios and almonds. But we also did a good amount of work in annual crops such as corn and tomatoes as well. And so I think the most strong point of validation that the technology is helpful isn't so much the academic research behind it, but how much our customers out here in California have loved the technology and renewed their subscriptions with us again and again. The thing that I hear from farmers that I'm most proud about is that we help make them better growers. They understand their agro ecosystems better by looking at the ET data. The ET data teaches them about how their fields work in a similar way that looking at your soil moisture will teach you about how your field will work. This gives you actual ET gives you a different lens on a different perspective on how the ecosystem works and teaches you insights about how that field works and makes you a better grower that can manage the field better and achieve higher yields and in our case out here, oftentimes quality is a goal as well. So here's a little bit more about what the sensor looks like. It's a first of its kind actual ET sensor for on-farm use. It's an affordable solution so that my scientific work, my academic work was in how to make this technology affordable. It tracks the actual use of the water use of the field over a broad area. So the way it's doing that is it's one sensor put out in the field, and it's looking at how that wind is carrying water vapor away from the field. And as that wind moves over a broad area before it hits the sensor, it's carrying a signal to that sensor, and that signal tells us about that broad area over which the wind has traveled. And the really cool thing about teaming up with CropX and what was so appealing about the CropX Thule acquisition was that with the CropX soil sensors and the actual ET sensor, you get this complete view of how the ecosystem is working from the roots all the way up through the shoots, as we like to say. Here's a quick snapshot of what some of the data looks like. So you'll get an ET summary. It's a card on the dashboard that tells you what the ET was for yesterday. In this case is 0.12 inches. The average for the last 3 days, also 0.12 inches, and what the ET was for last week, in this case 0.72 inches. You'll also see a chart view that shows you the ET over time in a chart. This is examples of the way that we are presenting the data. We have another way too where well, I'll pause on that for now. But there's lots of really cool ways that we visualize the data and made it useful. And so now I want to step back and talk about what we've already talked about. In conclusion, what CropX is providing with the actual ET sensor is a direct measurement of how much water the fields are using. It's not an estimate like reference ET, not an estimate like crop ET. It's not a, in my opinion, wild ass guess like um, remote sensing model. It's a direct measurement of what's happening in that field. And when you couple the soil moisture sensor with the actual ET sensor, what you get is a complete view of how that agro ecosystem works. So I want to leave plenty of time for questions because I recognize this is a new framework for how to think about crop monitoring and that some of you might have questions. So I'm going to stop there and um, answer questions.
Thank you, Tom. Ben, any questions in from the audience yet, or I can start with a couple things?
Not yet. So go ahead, John, while people go ahead
Okay.
and type in questions.
So one just clarification I can offer is like how to order and the stuff that you need. You know, this is a device-based measurement instead of just getting it, estimating it off of the weather and crop models, like everybody's used to. And so it does provide that field-specific higher level of accuracy and precision. Super unique in the industry. It's very differentiated. And the way that it works in CropX is it's the measurement sensor. Tom showed a picture of it. You order it in a bundle with the CropX telemetry gateway that everybody should know by now. That comes in a combination with like some mounting kit solution type of stuff. And then that becomes your package. Everything then plays well with CropX. So you go and you can install it and register it in the field the same way Ben was showing earlier. Just like Tom was showing on his screenshots, you use the same CropX app. It's all integrated. You can see this data up on the same dashboard as your soil moisture sensor data, and all of that stuff. So you order it through us as a bundle. It also is compatible with the CropX rain gauge. It also connects to our telemetry system, and the two can be used in one telemetry box at the same time. I think that's a very sensible add-on, low-cost add-on, so that you've got basically the whole water balance at that point. You got the rainfall, you got the ET, and then if you've got a probe in the field, that's just a very excellent combination. Tom, one question that I've had on the science side a couple of times as we've rolled this out is crop coefficients. People are used to hearing about crop coefficients as a ingredient in calculating ET. And the question that I've got is, well, what kind of crop coefficients do you use? Do you have crop coefficients for every crop type and my crop type and my hybrid? And I think the answer is forget about them. With this technology, you're totally bypassing crop coefficients. Is that right, that we don't need them?
That's right. And that's the biggest challenge with um, I would say this has been the biggest challenge of my career so far, has been getting people to let go of the old paradigm. Like you have to grab them by the shoulders and say, look, we're not modeling this anymore. We're not estimating this anymore. We don't need things like reference ET and crop coefficients. We can just directly measure it, or we can bypass it. We can just get what's happening in the field, throw out the old way of thinking about the world, bring in the new way of thinking about the world.
About the comparison of the usual reference ET that people get for free and this direct measurement of ET. Can you give an example of where they looks super different? Like, is it under certain weather conditions or crop health conditions or any examples that you can provide?
Yes, and I'd be happy to provide an example. And for me to feel comfortable in giving an example, I have to talk about the West Coast examples. That's what I've been doing for the last decade. So the example that always comes to mind is around almond orchards. Almond orchards are these big, tall canopies, so they intercept a lot more light than um, a turf grass field. And they also generate a whole lot more turbulence. The wind is a lot more effective at transporting water vapor away from a almond orchard than it is a grass field. So that means is that the ET, when a almond orchard is growing well and is healthy, is fully developed, it's a mature field, it's going to generate a lot more evapotranspiration than reference ET. So during the season, if you're just using reference ET, you're going to be underestimating the need of that almond orchard because that almond orchard is actually using 20% more water than the reference ET. You can actually take that. So that's just if you're using reference ET. Then the next objection to that is like, well, I'm smarter than that. I use reference ET times KC. And I can show you, I can't pull it up at my fingertips right now, but there's a huge variability in KC. So um, the KC
Yeah.
that's reported in the FAO literature is 1.1 for almond orchards, but it's actually, I've seen trees that are like 1.25. The
Yeah.
ones that are
And for
really
me,
healthy.
taking that to a corn and soybean situation, I used to work in the seed industry for a little while. There's a ton of variability per hybrid in the height of the crops, how the canopy looks, water use
Mhm.
efficiency. And so, the models that are out there, I can tell you, will typically use, one set of crop coefficients for just hybrid corn, for all hybrid corn. And it's growth stage specific, but there's no per hybrid numbers out there. Not even the seed companies have them. And so you go in wondering, well, for my farmer clients field and the new genetics that they planted, is this gonna be is this gonna be close to those KC values in the models, or is it not gonna be close?
Yes. And if I may, that's a great example. We see a similar thing out here with different clones, because everything is things are things are asexually propagated, plant materials uh,
Yeah,
cloned. But the the other situation that we often see is like during before when the trees are water stressed. So a common period that you might see a water stressed tree is right before harvest when they're intentionally trying to dry things down. We'll see ET values of the trees around like 1 inch when the field right next to it that they're not intentionally drying down has 2 inches of ET. So you can have this huge range in ET based on whether or not the plants are water stressed.
yep.
Um, so those are really the two main reasons that you might see differences in the actual ET compared to what you think the ET is. One is the canopy size and the effectiveness of that canopy genetically and morphologically at transpiring water. And the other is how thirsty those plants are and how much they're water regulating their water use.
I think maybe just a third one, Tom, and my memory might be off here, but I was thinking that you had a client that like found some disease impacts or like some other crop stressor based on the ET data. Like it was a time of year that the ET ought to be increasing week on week, but then it was like going down or flatlining or something like that.
Yeah,
Uh,
yeah. This is not something I normally bring up in the first webinar about ET. It's more of
oh,
like an
sorry.
advanced ET concept,
Okay.
but this is a grower that closely tracks their actual ET, and he realizes, hey, my actual ET of this field isn't where I want it to be. It should be higher this time of year. So he goes out there and looks at the field, and there's a common fungal leaf disease that occurs in pistachios, and there was an outbreak that reduced basically the effective leaf area of that field. And his yield was hurt that year. So next year, uh, part of their between season planning was to um, develop a more rigorous plan around preventing that fungal disease. And they prevented the fungal disease better, and they had higher ET because there wasn't a reduction in effective leaf area due to
Yeah.
necrosis from the disease, and they had higher yields.
Yep. Yep. Interesting. Um, Nick or Ben, I think we've got a wrap. Any last words?
Nothing on my end. Great job, everyone.
I'm good.
Thank you, everyone.
All right. Thank you very much, everybody. Have a great one.